I'm a tech entrepreneur, but sometimes people must misunderstand that and they think that I'm a tech entrepreneur. Uh, well, that's also accurate. I am a big nerd that started back in the 80s when I got my first, I even brought it with me. Can you see it? My first computer, a Commodore 64. I'm sure a lot of you also know this computer. It's still in the Guinness Book of Records as the best-selling computer of all time. Eat that, Steve Jobs. But that was back in the 80s. I started to learn programming, and those were actually my first steps into the world of AI. Of course, I didn't know the term back then, but I had a lot of fun creating computer programs that I could interact with. I know this sounds pathetic, but it also says a lot about my youth. And now, as Mondeka said, I actually run a company that is called Agency and Artificial Intelligence Agency, which means that we use software, we use data, all kinds of ways to make machines look smart and help you solve problems or help you do better. And that is what I would like to discuss in this talk. As you can see, agency is with AI, Artificial Intelligence Agency. But besides that, I also run a non-profit, a not-for-profit, a stichting, a foundation, which organizes a free online course. It's called the Nationale AI Cursus, or the Dutch AI course. It's also in English and in French lately. And what we try to do is to educate as many people as possible about the basic principles behind AI, because we all know that artificial intelligence will play a big part in our future, but not everybody understands what AI is or what the impact will be. And of course, we are very much inspired by Hollywood, by Terminator and RoboCop. That's all science fiction. I'd like to talk to you a little bit about the science behind AI. And that is what I'm going to do now. So it's basically the National AI course squeezed into 30 minutes during ESA Space Bites. If you like this topic, if you want to know more, as I said, this is an introduction, then you can take the full course, of course, in your own time. It takes for about 5 or 6 hours, and afterwards you get a diploma, a certificate, and that way you're fully prepared for the talk by Simone, who will be talking about artificial intelligence in the next ESA Space Bites in March. Right. So what are we talking about? Well, the first thing you need to know about AI is that AI is not one thing. This is actually why many discussions go off the rails, or why people don't really understand what it's about. They think it's one thing. It's not. It's a container word, a suitcase word. It means a lot of different things to a lot of different people. And as you can see here on the screen, I have highlighted my 8 favorite techniques. So just consider AI to be a set of technologies that you can use to make machines look smart. A set of technologies that you can use, you're in control, to make machines look smart so that they can do the heavy lifting for you, right? And it all starts at the top left with machine learning. In the AI field, we thought that it was rule-based. If you just had enough software, enough code, if this, then else, but that only gets you this far. Because of the breakthrough of machine learning, we have actually seen many interesting breakthroughs in the last couple of years. If you go from left to right or top to bottom, it's just adding layers of complexity. But it starts with this notion that we found ways to train a machine. And if you think about that, that is a mind-blowing concept, because how does a child learn? Well, it looks around, looks for examples, it sees people walking, and it tries to walk itself. So a child learns from examples. A computer also learns from examples, except we don't call it examples, we call it data, training data. Well, the world is full of data. More and more systems are connected. Processes are digitized. We are working digitally, so we're very data rich. And then if a child starts to try to walk, it trips over, it falls. We learn by trial and error. A computer also learns by trial and error, except we don't call it trial and error. We call it an algorithm. So this is a word that you hear mentioned a lot. An algorithm is doesn't need to be complicated. It's just a set of instructions that you can follow to solve a problem. For example, find patterns in data. Now, and in the end, a child, a human being, we have experience, intuition, gut feel. A machine doesn't have all that. A machine just has statistics, probability theory. It's good at math. So here we go. I'm going to try to talk about all these concepts. And the basic premise is that I want to inspire you to think about, at ASA, yeah, we have a lot of data. How can we use that for good? So I'm sure you're data rich, but most organizations are data rich, information poor. I hope to inspire you to think about these algorithms, these computer models, to actually go to information rich so that you can do kick-ass stuff. Right, let's start with machine learning. Machine learning is all about structured data. So if you can think about the data in a Microsoft Excel sheet, it's probably machine learning. For example, if you watch Netflix, then Netflix has algorithms that look at your historic data, series and films that you've looked at the past, and if you've rated them, good or bad, and based on that data, on these patterns, they suggest movies and films for you. They also look at people who look a little bit like you, and they do these suggestions. So basically, a recommendation engine is also AI, something that we use in the daily life. Also, machine learning is very good at optimization. For example, route planning. If you order your groceries online, then if they get delivered, it's basically a machine learning algorithm that has tried to calculate the optimal route to get there as cheap as possible for them and as convenient as possible for you. So machine learning, as I said, is like the entrance level. We've been doing this for many years, since the 80s, basically. This is not very new, but what is new is that you can do cool combinations with it. For example, if you look at the top layer of structured data, then you now know that machine learning is about looking at all these ones and zeros, finding patterns in the data, and then the algorithm, if it knows what a pattern is, it can predict or classify or cluster. Well, if you apply that kind of thinking to a database of websites, URLs, you've built a search engine. Google is basically one big combination of all these algorithms that are very good at machine learning, at information retrieval, giving you the right website even before you finish the keyword that you were searching for. And if you apply this kind of thinking to a database of conversations, you've built a chatbot. It doesn't need to be very complicated. If it's a narrow domain, a chatbot can answer 80% of the questions as long as you stay on topic. If you want to discuss other things, then it doesn't know what you mean and it will give you back silly answers. But as I said, this is the top layer of structured data. This is basically what we've been doing for years. And you see also new companies emerge that are basically AI companies that enter a certain industry. This is, for example, Lemonade. Lemonade is an insurance company. And usually when we think about insurance, we think about skyscrapers and a lot of people in suits and dealing with paper. Well, actually, Lemonade has says from the beginning, we want to be as digital as possible. So instead of buying a building, they build an app. Basically, it's an insurance company in your back pocket. Wherever you are, the app knows where you are. So if you want to have a insurance on your house, the GPS knows where you are. It does the math based on your zip code. It compares your situation to other people in that building block, and it can give you a good value for money. So a proposition. And with 2 clicks, you can actually say, yes, I want it. So it's more like a WhatsApp conversation, except you're not WhatsApping with a person. It's a bot. It's a chat bot. And based on all this historic data, they have a very high price performance, price versus quality rate. So they're doing very well. They're growing very fast. They started in the United States. They moved from state to state, not by adding more people or adding more buildings. No, just adding lines of code. They've even crossed the Atlantic. They're now in Germany, and last year they've also entered the Netherlands. So they're growing very fast, not because they have a lot of people, no, they have a lot of bots, not because they have a lot of paperwork, no, they have data, and because they use smart algorithms to actually deliver a customer experience that is beyond what you would expect. They even set the world record from someone filing a claim until payment within 6 seconds. That is not the experience that you might expect from an insurance company, yet Lemonade delivers on that promise. So this was just a little starter. As I said, the top layer, structured data, is something we've been doing for many years. But as we all know, the world isn't structured. There's a lot of unstructured data, unpredictability. So I want to talk now about the second layer. And as you can see, 2 examples of that is computer vision and natural language processing. And these are large data sets that cannot be imported into Microsoft Excel, right? So Excel is structured data. If you import a photo into Excel, it says syntax error, or it doesn't know what to do. Well, we need new technologies for these, and these technologies are called deep learning. So deep learning is a subset from machine learning. It's still the basic concept of learning from data, so finding patterns in data, but deep learning can also deal with large unstructured data sets. For example, thousands or perhaps millions of photos. And if you train a deep learning algorithm, for example, with photos of dogs, and every time you show it a photo of a dog and you say, this is a dog, then the algorithm will try to find, okay, what are the pixels that define a dog? And then after 100,000 examples, the system is pretty confident about what a dog is or how the pixels look like. Then you show it 100,000 photos of a cat and you say, this is a cat. And again, it does the math, it adjusts its parameters, and then it can identify a cat if that is in a photo. And this is very basic stuff, of course. If you show it a photo of a rabbit, it says, I don't know, 50% dog or 50% cat. It doesn't understand the concept of these animals. But if you have enough examples, the model will be able to recognize a dog in a new situation, even a dog that it has never seen before. But it takes a lot of examples. Let me give you a use case for this. This is just a couple of blocks down the road in Amsterdam. As you know, we have the canals. These are very narrow streets. And if the garbage truck goes its route, that is a hassle because there's too much garbage, or the truck is too big, or the route is not optimized. So what they did at the municipality of Amsterdam is they trained a deep learning algorithm not to recognize dogs or cats, no, garbage bags and other pieces of trash that the people in Amsterdam put alongside the road. So it's not the garbage truck that goes the route, it's just a little car that goes around with a camera that has been equipped with this deep learning algorithm, and it does the math. It knows exactly how to headquarters so that the algorithm can say, okay, this is the route that you should take. And by the way, perhaps first go there and there because there are some mattresses and we want to pick them up before it starts raining, right? So a very big problem solved with a small piece of software, a deep learning algorithm that is already on the shelf, except it's not trained on dogs or cats, it's trained on garbage bags. Right. And I know what you're thinking. Because, okay, so if you can train it to recognize dogs or cats or garbage bags, perhaps you can train it to recognize pixels in someone's face, right? We all have this unique print on our face. And that's called face recognition. That's also a technology that you've heard about a lot. It's basically deep learning, except the model isn't trained with pets. It's someone's face with a label. This is Jim Stolze. And if you show it enough pixels or enough photos of Jim Stolze, it will be able to recognize Jim Stolze in other situations. But that is complicated because what other situations are there, right? If I'm at the airport This is Schiphol Airport, and at Schiphol Airport there are some areas that are restricted to the general public. Not everyone can go there. So they use face recognition, and in this case, Marie Williams, she has clearance to be there. So the camera sees Marie and says, okay, that's okay. And then we see Pedro Luis, he is also welcome, he's a contractor, he's there for a week. But then behind those two persons, there's one person, and then the system will say, security, we have someone in the restricted area who can be there or should have his photo taken, yes or no, right? So in some situations, face recognition can be of added value. In other situations, we consider this a invasion of our privacy, of course. If I'm in the if I'm out there on the street, on the public street, then it's not okay for me to have all these cameras say, hey, that's Jim Stolze, let's track him. But opinions differ across the world where you go. For example, in California or in the United States, the big tech companies have said that they stopped selling this technology, so face recognition, to the local authorities or to the police department. Why? Because they developed a conscience? No, because their technology sucked, basically. It worked very good with people with light skin, but people with a darker skin, it was a mess. So it was bad technology used in a bad way with bad ethics. So that's the reason why they said, okay, we're going to stop this. We're going to work on it to be better. And the debate is still happening about what does that mean. In other parts of the world, for example, Singapore, they say, that's interesting. So you can use your face as an ID. Okay, let's use that then instead of a passport. So that's a completely opposite view. As I said, the debate is still going on, as is with a lot of technology in the field of artificial intelligence. In my work, I thought that I would be talking a lot about the technology. Actually, the technology is only 20% of my work. 80% is about ethics. Okay, can we do this? Should we do this? How can we do this in an ethical, in a responsible way? And that's important to have these discussions. I mean, in the past we thought, wow, we would like to do this. Is that technologically speaking possible? But now we know it's possible. But the question is, should we? Right? But the technology still moves on. It gets better and better. There are now companies that specialize in one particular piece of AI, for example, reading someone's face and then using emotion analysis, trying to guess how this person is feeling. So it's the same technology. Show photos of a dog, show photos of a cat. In this case, show photos of a person who said that at the moment that this photo was taken was feeling sad or happy or enthusiastic. And they're actually selling this technology to companies right now. And again, we haven't decided if this is ethical or not. I've never given permission to have my face scanned and my emotions analyzed. So this is a blue ocean, as we say. And the biggest, I think, challenge of AI is, as I said, not the technology, is how we can use it for good so that everyone benefits and not just the tech companies. This is why I started the AI course, because AI is too important to leave up just to the big tech companies. Everyone should know about it. Everyone should think about it, and everyone should co-create it in a way that it makes sense for society. That's the only way that we can make this technology work. We don't need a technology push from governments or a technology push from companies. It's something that I think should be led bottom up. So let me give you some examples how, for example, deep learning technologies are used for good. So not just by the social media companies, but by other institutions. AI for Good is a international movement of people who want to use AI to help progress with the field of the Sustainable Development Goals. So, for example, if you look at global health, what they did was develop an app that can help people. In this case, this photo was taken in India. In India, a lot of people suffer from a disease, an eye disease called diabetic retinopathy. And 40% of the people who have this condition, they turn blind. They lose their vision. Why? Because there are not enough doctors to actually give you the diagnosis. Say, okay, you have this condition, you need surgery right now. You need to go to the hospital. But a lot of those people live in hours and hours away from hospitals, so they don't have the time or there are not enough doctors. So what they did was train a deep learning algorithm. There we go again. You show it enough photos of the back of the retina, 130,000 photos, of which a medical doctor, so an ophthalmologist, said, okay, on a scale from 0 to 5, this person is okay. There's nothing wrong with this retina. Or this is bad news. This is someone who needs to go to the hospital. So they trained the algorithm, and now anyone with a smartphone can take a photo of its eye, and then the app will give you back, you're fine, or you need to go to a hospital. So that is a very good example, I think, of an AI application in the field of healthcare. The Red Cross also uses AI, or they're helped by AI companies to render new maps. For example, if there's somewhere a natural disaster, then the maps of that region have rendered useless. You can't use them anymore. So the river is now over there, and those buildings are no longer over there. So what they do is they use a deep learning technology based on satellite imagery to come up with new maps, so that the first responders, if they go to that location, they have maps that they can actually use. And finally, another example that is dear to my heart. This is for the deaf community. So children who cannot hear, they also like to be read to, right? Bedtime stories. So what this app does, it's called Story Sign. You can point your phone on the book, and then the app will tell you in sign language what the story is about. So these deaf children are actually read to in their language, thanks to AI. Another example of how you can use artificial intelligence for the greater good is a bit closer to your home. And I'm sure you're all familiar with, and I'm a big fan of Space for Good. There's actually a spin-off or a startup that started at the ESA incubator, at the business school, so to say. And what they use, or what they do, is the same as the example of the Red Cross. They use satellite data, a global information system, artificial intelligence, local knowledge to, for example, look at a map and say where deforestation is happening or illegal logging. Or they work together with Willie Smiths to help the orangutans to live better in the rainforest. So he has this methodology to redesign it. As you can see here on the screen, what they do is they use these satellite data, and they use local expertise and artificial intelligence to actually accurately map the deforested areas and alert local authorities. So I think that's a great example of how you can use data and artificial intelligence for a good cause. Right, we're almost there. Hope you're enjoying your lunch and the food for thought. So far, I've spoke to you about structured data, so the top layer. Then we discussed deep learning, so unstructured data. Something right now, but the next layer, the bottom third, so to say, is the layer of experimentation. So this is still in the labs. This is very early days, so to say. As you can see, reinforcement learning, that might be the next thing, but it's currently very slow. It's a whole new approach of machine learning. It's not supervised, it's not unsupervised. It's basically giving a machine a lot of data and give it a proper instruction. So what is the problem that you need to solve? A reward function. Give it time, give it data, give it computing power, and it will come up with a solution. This might feel like a black box to you. At Google, they call this knowledge without understanding. So it's very impressive, but we don't really know what's going on. Next to that, you see generative adversarial networks and generative pre-trained transformer. These are two very exciting fields or technologies that you can call artificial intelligence. And the big difference between the other ones is that so far, I've talked about AI as analyzing data, consuming data points. Well, these models can actually create or synthesize data. And perhaps you're thinking about deepfakes. Yeah, that's actually what this is. So what they do is they train a model on the face of Mona Lisa in this case, and then they point a camera on my face, and when I move my nose, my eyes, my mouth, what they do is they manipulate the pixels in her face to match the movements that I make in my face. So I move, she talks. This is, I think, history lessons have become way more interesting in this way. And we're also seeing new faces online. These are synthetic avatars. As you can see, Samsung has these people are not real, right? These are digital avatars, chatbots that look very human-like, or soul machines that's being used in health, or Synthesia. This is a chatbot that actually has a face. You can type in your text, and then she or he, depending on the avatar that you choose, will give that message to the people you send it to. So this is an interesting moment in time. From now on, you can no longer trust your eyes on the internet. You have to think about, is this real or is this fake? Is this synthetic? And this brings me to the final technology that I would like to talk about. It's GPT, generative pre-trained transformer. And this is sort of a deep fake. So it's creating not pixels, but it's creating text. And I must say, I've given lectures at ESA before, and the last time when I was there, this wasn't even a thing. Just to illustrate how fast AI is growing. What is it? Well, it is a very impressive language model. It's a product of OpenAI, which is a research collective based in San Francisco. It's funded by Y Combinator, Elon Musk, and Microsoft. And what they do is research deep learning or AI, and then make it accessible to the academic society. So it's not a tech company that does it for their own R&D. It's for the greater good, for science in general. And they have trained the largest language model in history. Every text that is on the internet probably was part of this model. We think of Wikipedia. Wikipedia is a large website, right? Well, that only accounts for 0.6% of the total language, the body of language that this model was trained on. So what they did was train the model on all these texts to find out which words go together, which sentences go together, and then create new texts that seem real, as if they were written by a person, but it's new, it's generated. The way it works is that you give it a head start, a prompt. Well, think about your phone. Sometimes when we're typing a message, we are lucky if it guesses, it auto-completes one word. Well, GPT-3 can do the same, but with an entire email. What? Yes, or a song lyric, or an annual report, or HTML code. It doesn't matter what the form is, as long as you give it a prompt, a little start, and you hit transform, then GPT will use that language, that form, that style in the number of words that you give it, and the temperature, how crazy, how creative it can get. And I've seen many examples of it. I even got to play around, and it's a great transforming tool. So for example, if you have a mathematical equation that you can say in natural language, then GPT will give you the right mathematical formula for that. Or you can use it in spreadsheets. Right? Usually when you have a Microsoft Excel, it can only autocomplete what is in the Excel sheet itself. Now you can use GPT-3 to actually import stuff, autocomplete from information that was not already in the Microsoft Excel sheet. So this is really a game changer. We can use it in so many ways. If you have a text that is very full of legal jargon, that's very hard to read for ordinary people, you can just hit transform and it will rewrite the same language, the same text, but in a way that people can actually understand it in the style, in the language that you choose. So, whew, it's been like a roller coaster, a crash course on all these parts of what we call AI. It started with machine learning, the basic notion of understanding how machines learn. And then from left to right, from top to right, we've now come to the moment in time where we can no longer trust our eyes and ears. From now on, if you read something on the internet, you probably must think it's fake until it has been proven real or authentic. And this brings me to my final point. When I started out, I said I'd like to tell you a little bit about the science behind AI. There are many ways that you can that you make machines look smart. But the way we think about AI is basically fed to us by Hollywood and these scenarios of machines becoming self-conscious or developing their own agenda. That is science fiction. If it's going to happen, it's so far away that I don't think we have to worry about it during this lunch break. What we can do better is to actually think about how we can develop, how we can work alongside, how we can generate robotic and AI solutions that are to the benefit of society. So we don't have to fear AI. We have to work alongside it and do great things here on Earth or in space or during your lunch break. So thank you so much for your attention. Space time.